Okay, very similar problem to the last one. We are going to use A of t equals A of sub 0 e to the kt. And here we definitely need to keep k exact. They ask you to enter it that way on the quiz. So in 3 years, 30% of a radioactive element decays. That means that there's 70% left. So if I started out with, I don't know, if I start out with, say, A sub 0 is 10, if there's 70% of it left, then the remaining amount would be 7. So I'd have 7 equals 10 e to the kt. I could use numbers, but once I do my division, I'm looking at 0.7, which is 30% has gone away. So don't do this. You don't have to make up numbers, just use the number they give you, and we don't have to worry at all about the starting amount and the ending amount, at least not when we're solving for k. And that happens after 3 years, so let me substitute a 3 in for t. And again, we're applying a common log to both sides. Yeah, not a very good substitution. So ln of 0.7 is equal to 3k, because the ln on the right-hand side canceled out e. And we're just going to divide by 3. Divide by 3. K is exactly equal to ln of 0.7 divided by 3. And that's what they expect you to enter. All right, so this is a carbon-14 problem. And what we have to do is, the first thing we have to do is take the half-life idea and figure out what K is, because we're working with, again, A sub 0 equals E to the KT. Well, if they started out with half-life or anything like that, then you know you're going to use this exponential model. All right, so in order to solve for K, we're going to put in the T of 5,700 years, and that's how long it takes it to reduce to 1/2 of its original amount. So 1/2 of the original amount is equal to E to the K times 5,700. All right, so we're going to take the natural log of both sides, and what I get is, I'm going to use 0.5, it's just easier to put in the calculator. Ln of 0.5 is going to be equal to 5,700k, and I'm going to divide by 5,700, which gives us k is equal to ln of 0.5 divided by 5,700. So my equation is A equals A sub 0 E to the ln 0.5 divided by 5,700. Now we can use that equation to answer the question of how old is the bowl if only 35% remain. Again, I could start out with some numbers as A sub 0 and A, but what I know is going to happen once I do my division is I'm going to get a 0.35 on the left-hand side. Okay, so to solve this, I take the natural log of both, I goofed because this is supposed to be ln of 0.5 divided by 5,700 times, this whole thing gets multiplied by t. Okay. And the thing I'm solving for here is t. So when I take the natural log of both sides and then divide by this, I get t is equal to ln of 0.35 divided by, and again, we need parentheses when we're dividing by ln of 0.5 divided by 5,700. All right, to the calculator. Okay, I'm going to divide that by ln of 0.5. No, I need parentheses. Otherwise, it will not do the right order of operations. Divided by 5,700. and my parentheses on the division in the denominator, and here we go. So the bowl looks like it's at 8,633 years. I think they ask you to round it to the nearest, 100 years. So that's going to be t equals 8,600. Okay. Again, more of this exponential, exponential decay growth using the A times e to the kt. So we have an isotope of lead, 201 Pb. It has a half-life of 8.6 hours. How many hours ago was there 20% more of this isotope? I kind of struggled with this one because these are getting bigger. So same idea. We're going to take the half-life of 8.6 hours. So 1/2 equals e to the k times 8.6. All right, so solving for k, I take the natural log of both sides. I get ln, and I'm going to divide by 8.6. ln of 0.5 divided by 8.6 is equal to k. That gives me an equation to work with, which is a equals a sub 0 e to the ln 0.5 divided by 8.6 times t. All right, so an isotope of lead has a half-life of 86. How many hours ago was there 20% more of the isotope? So 20% more, let's say we started out with half-life of 86. How many hours ago was there 26 more? Yeah, 20% more. So instead of having less than 100% on the left-hand side, we're going to have more than 100%. So 20% more is going to be 120% in decimal. That's 1.20. And that's going to be equal to e to the ln 0.5 divided by 8.6 to the t. So if I take the natural log of both sides, I'm going to get t is equal to ln of 1.2 divided by ln of 0.5 divided by 8.6. So do the calculator, 1.2, 0.5, 8.6. Now, they're asking us how many hours ago. We should expect a negative here. Yeah, and we do. Negative 2.26. Don't have any rounding instructions, so we'll just leave it at negative 2.26 hours ago.